This session will be on the energy transition. So energy is a fundamental aspect of our society, our economy, our health, and our security. And we recognize the necessity to reduce our dependence on gas, oil, and coal, which leads to elevated greenhouse gases when burned. The EU and Ireland are making important headway in driving policies and research to support the growth of renewable energy and decarbonization in order to reach net zero. In this session, we'll showcase a number of projects across iCRAG that are tackling energy transition challenges in the areas of geothermal energy, geological storage, wind energy, and stakeholder engagement. Our speakers today are Vincent Roche from UCD, Duygu Kiyan from Duygu, Pablo Rodriguez-Salgado from UCD, Andy Wheeler from University College Cork, and Josie Taylor from UCD. So the first topic we'll be dealing with today is going to be geothermal energy. Across Europe, geothermal energy has been used for decades, such as in Italy. However, there's renewed momentum for decarbonization and energy security. In addition to initiatives such as the Net Zero Industry Act, recent developments, such as in December in the European Parliament, approved the promotion for faster deployment of geothermal energy and called for the European Commission to prepare a European Geothermal Action Plan. And this will address issues such as tackling upfront financing as well as permitting. In Ireland, progress includes the government's commitment in their recent policy statement and upcoming legislation for regulation. iCRAG and its numerous funding partners are working together to understand and characterize Ireland's geothermal resources through reservoir characterization, geomodeling, and geophysical methods. So I'd like to hand over now to Vincent Roche to tell us a little bit more.
Okay, thanks, Cara, for the introduction. I'm Vincent Roche. I am a research scientist here in UCD iCRAG. And today what I'm going to show you is an overview of iCRAG research projects which are supporting this geothermal energy development. Okay, so the first project I'm going to talk about is called the National Geothermal Database. And this is a project supported by the Geological Survey of Ireland. This is a regional approach with the objective to reduce risk in geothermal exploration by providing subsurface data with a specific focus on the Carboniferous Basin onshore Ireland. And so in this project, we use a large amount of data, including boreholes, seismic data, surface data, to build this large-scale, high-resolution 3D model of the Carboniferous Basin. And this model provides key information on the depth and the location of the geothermal reservoir in the area, as well as the data gaps. And also, we have been using this model to assess the geothermal resources using the heat-in-place method. And all that are fundamental outputs which will be available for the public and the stakeholders. The second project here is called GeoNorm, and it's also supported by the Geological Survey of Ireland, as well as the Sustainable Energy Authority of Ireland. This project uses a similar approach as the National Geothermal Database project, but at a smaller scale, with a specific focus on UCD campus, so here. And in this project, Pablo and his collaborators has been using those well data from UCD estates to build this high-resolution 3D model of the subsurface geology here beneath our feet. And together with tailored petrophysical characterization, this model has been used again to assess the geothermal resources on the campus, which could contribute to the heat demand of the different buildings in the campus. And this includes shallow resources and deep resources. The next project I'm going to talk here is led by Zili from UCC and its collaborator. And this is funded by CET Partnerships and CODEMA. And this project explores a different concept for geothermal energy, looking at the potential of tunnels as heat exchangers. And specifically, what Zili has been looking is at how we can utilize Metrolink, which is the proposed line of metro across Dublin, to form those large-scale district heating and cooling system network in Dublin. And those could contribute to the, the huge heat demand in the populated area of Dublin. The Gallery-to-Calorie project is another project which is exploring this idea of using underground structure for geothermal energy. So this is a project funded by Geothermica and also the Geological Survey of Ireland. And, but in this case, this project focuses on the geothermal potential of tunnels due to galleries due to mining. And in this project, Pablo, which is also leading the research here, and his collaborators, has been building this 3D model of a legacy mine in Scotland using historical data. And he has been looking at the potential of this mine as a geobattery to store the excess heat from the Edinburgh Parallel Computing Center, which is nearby. Okay, and the final project I am going to address here is a new project that just started, which is called Gemini. This is a large 20 million euro project, which is funded by Peace Plus Northern Ireland and Ireland. And this project aims to demonstrate and promote the uptake of efficient, renewable, low-carbon, secured, and affordable geothermal energy, with a specific focus in 4 different areas, 2 in Northern Ireland, 1 in County Sligo, and 1 in Dublin. And amongst the 15 partners which are involved in this project, one of the research components that will be led here in UCD will be to do some 3D modeling, including geological modeling, fluid flow and temperature modeling, as well as assessing geothermal resources and some reservoir characterization. And all that will be fundamental milestone to demonstrate the feasibility of geothermal energy in Ireland. Now, another research component which is fundamental for this project is the acquisition of geophysical data. And I'm going to let Duygu talk about that specifically for this project, but also for other projects. But before that, I just would like to thank all the sponsors which has been funding all these different projects.
Thank you, Vincent. Hi, everyone. My name is Duygu Kiyan. I'm a research fellow at the Dublin Institute for Advanced Studies. And today I will be talking about the iCRAG geophysics platform activities, which are focusing on the geothermal energy research in Ireland. So the geophysical methods are an integral part of the framework, including surface geological mapping, geochemical sample collection, analysis, well data analysis, etc. Geophysical methods allow for better subsurface models and more accurate conceptual models, as they are the only tools that provide information on the geothermal reservoir geometry away from the boreholes. For example, seismic data provides structural images. Electromagnetic methods such as magnetotellurics are sensitive to properties such as pore space, fluid saturation, hydrothermal alteration, minerals, and fluid movement. The gravity method provides effective mapping of the basement surface and provides additional constraints on the porosity structure. So we first start with the DIG project, which received significant funding from the Sustainable Energy Authority of Ireland and Geological Survey Ireland. The project aimed at exploring potential for low-enthalpy geothermal energy on the island of Ireland using a 3-scale approach. The main objective is to create an improved resource map of Ireland. To map the temperature and the geothermal gradient at the at the scale of entire Ireland, we integrated all relevant data sets by means of geophysical petrological inversion. In this project, we use new large seismic data, surface heat flow, thermal conductivity, and radiogenic heat production data sets to determine the temperature variations within the lithosphere. And we produced a subsurface temperature model for Ireland with its associated uncertainty on the left. And we also produced new MOHO and lithosphere-asthenosphere boundary depth maps for Ireland. These models are undergoing peer review at the moment. The final models will be available to the community through publications, but also through Geological Survey Ireland's online interactive maps. At a local scale, our DIG project focused on the Malov region. The area, it's here, the area has thermal waters with an average temperature of 19 Celsius degrees. We used magnetotelluric and passive seismic geophysical methods to actually image conduits and pathways supplying the thermal waters to the surface. This is led by Duygu. UCC is leading the 3D structural model for the region. They are using our geophysical models to constrain their 3D structural model. We also have a hydrochemistry program, which is also led by UCC. And these are some images from the survey area. You see some, this is the electrical resistivity model from the region using magnetotellurics, but we also have some 1D velocity models from the passive seismic surveys. Our second project, as you heard from Vincent, is our new project is called Gemini. The geophysics component of the Gemini will include passive seismics, MT, and gravity data acquisitions in Antrim in Northern Ireland to improve our understanding of the subsurface. We are also going to collect some petrophysical, we are also going to do some petrophysical measurements on the selected rock samples at the UCD Petrophysics Lab, which will guide the geophysical modeling. Also, Gemini will establish a temporary seismicity network at the Technical University Dublin Grange Gorman site before drilling commencing, and will be in place for the duration of the drilling activity and for a period after. And we will also have a seismic network in Antrim too. So these networks of sensors will be designed specifically for the locations and planned activities and will measure all local seismicity. The result will be a baseline measurement of all natural and human activity. So this map here is produced by Irish National Seismic Network, and we can see that there are not so many earthquakes in Ireland and generally of low magnitude. But within Gemini, we will have more focused seismic networks around the drilling site and also in Antrim. All these projects and also our international geothermal projects are supported by our national magnetotelluric infrastructure called MASTER and a seismic instrument pool hosted at Duygu. In summary, iCRAG lead a diverse portfolio of projects dedicated to supporting the growth of geothermal energy in Ireland, leverage wide range of data from industry, academia, and construction sectors. iCRAG use advanced techniques and expertise from 3D geological modeling, multi-scale, multi-dimensional geophysics, sedimentology, petrophysical characterization, structural analysis, and engineering, and we investigate broad systems. Thank you very much.
Thank you, Duygu. So my name is Pablo Rodriguez-Salgado, and I work in UC the iCRAG in different topics around geological storage and geothermal energy. I was actually one of the first PhDs starting working in iCRAG back in 2015, and it's been great to see iCRAG growing through these years. But today, anyway, I'm going to be talking about our research around geological storage. So geological storage refers to the storage of fluids in subsurface geological formations. And these fluids involve CO2 from industry activities, or we can also store energy in the form of methane or hydrogen. Currently in Europe, energy storage is ramping up, and there is over 190 projects in different stages of development. For example, we have carbon capture and storage project in Norway, Northern Lights, which is ready for injection. Also in the Netherlands, Porthos project, which is being currently developed. And also a large number of projects in early phases of development. Looking into Ireland, currently there is not an established legislation, but significant steps are being made on that direction. Meanwhile, in iCRAG, we are getting the research part done and working on it. And one of the reasons we are working on this topic is because the Irish offshore sedimentary basins host great potential for storage. And there are different reasons. For example, the basins have a broad range of different geological formations, so they can support conventional storage, in which you have a permeable rock sealed by another impermeable rock. But they can also support other types of storage, as they have, for example, thick salt accumulations, where we can develop human-made salt caves to store hydrogen. The basins also, or large part of these basins, are located around the shallow waters of the continental shelf, so they are more easily accessible for development. And finally, but not less important, these basins have been extensively explored in the last 40 years, leading to significant both commercial and undeveloped hydrocarbon accumulations. And these accumulations, in fact, they prove the presence of rocks capable of storing fluids through extended periods of time at geological timescales. Over the last 10 years of iCRAG research, a significant number of projects have been conducting research in the Irish offshore sedimentary basins, covering different aspects like structural and stratigraphic characterization, tectonic evolution, and so on. And this research has allowed us to develop an in-house expertise and a large database, including geophysical data, exploration boreholes, key geological interpretations. This is very timely for the energy transition, as we can now use this data and this knowledge to de-risk geological storage projects. And we have actually currently completed this project, which has assessed the storage potential in the Celtic Sea basins. Here we can see different traps that we have characterized. And we are currently planning to expand this research to include the broader geological formations and basins on the continental shelf. This project aims to produce not only results that they are scientifically relevant, but also outputs that will be ready to be used by industry and policymakers. So in conclusion, we believe there are great opportunities, and I believe that if we work together between academic institutions, industry, regulators, there is really the potential to place Ireland at the forefront of geological storage in Europe, and iCRAG is ready for this. Thank you very much.
Okay, hi, I'm Andy Wheeler. Ireland has set an ambitious target to create 80% of its offshore, 80% of its electricity supply through renewables. And the challenge there, we've got about 30% so far. We've got 5 years to get 7 gigawatts of offshore energy, which is a big ask. The land capacity is largely full. The history of developing offshore renewable wind energy has been problematic in Ireland since 1999. We built our first wind farm. We started off with a very good developer-led approach, and iCRAG has been there, giving advice, giving support, creating data, giving knowledge and expertise to help de-risk these wind farm prospects. I've been working on Irish shelf sedimentary systems and subsea bed architecture for 25 years. I don't want to blow my own trumpet, but within iCRAG, the amount of expertise and longevity of that expertise, we really do know the most about what's going on in our offshore and in our subsea beds. We have a huge amount of expertise to deliver. So we were very happy in the Offshore Renewable Development Plan 2 to myself and Mark Corlin to be part of the advisory group to help inform that process, to help de-risk. And that plan then led to a pivot in Ireland's approach, which is now state-led. We have designated areas for offshore wind farm development for licensing, and that's part of a marine spatial plan. So iCRAG has been doing a lot of work over the years, helping developers and now helping DEC and state agencies as well in trying to de-risk these areas. I just want to share a flavor of some of the things we've been doing. We've obviously been developing ground models. We have a lot of experience in seismic data and in seismic interpretation, using single channel and multi-channel. Up in the north part of the Irish Sea up here, we've done extensive work producing ground models, 2 in situ CPT campaigns, working with GDG, but also working with Gale Electric Developments that was SSE and now Statkraft. Statkraft came to me recently and said, thank God you developed that stratigraphic model for that area. It really, really helped us interpret some of the data that they've been developing. And these ground models are quite complicated. There's a lot of interactions between glacial advances and retreats and outwash, et cetera, so they're not easy. The southern area down here, we also developed ground models down here. This has become a very important area, will be the next area that's licensed. This is the only public domain stratigraphy for the area where 2 ice sheets meet, where there's also sea level interactions, there's buried interglacial deposits, variable bedrock, et cetera. Not only have we been working on ground models and the subsea bed, we've also been looking at what happens at the seabed in terms of sediment transport, in terms of scour, in terms of risk, in terms of gas escape, in terms of a whole other factors which are very important when assessing where to build your wind farms and what you need to mitigate against, and also trying to develop new advanced technologies to image below the seabed using passive acoustic approaches, using fiber optic cables to add a bit more light, a bit more structure, another way of trying to get more and more detail out of this data in a way that's extremely cost effective and complements other techniques, particularly in areas where it's particularly hard to get acoustic reflections. Just last month, we ran a very interesting workshop. There's a poster outside where we invited a whole load of developers, government, fishermen, fisheries organizations, NGOs into one room to discuss where they thought they would like to site a wind farm, and they fed in their views into a multi-criteria decision support tool, which we've developed for a theoretical wind farm in the Northwest Broad area of interest. So we get an idea from the different stakeholders where they perceive it is good from a developer perspective, from a public perspective, from a fisheries perspective. That highlights also where there's conflict, where there's synergies, and how you can work with these different stakeholders to make a route to market and come up with sensible decisions, taking everything on board. So where do we go next? There will be a series of license options released later this year for offshore renewable wind energy. To Nua up here is the next one off of Tremor Bay. This is where we have released our seismic data into the public domain and build a stratigraphy for that. iCRAG is here to help and assist developers, government, ENGOs or other organizations in trying to make this a reality by providing a data-driven approaches to site selection and de-risking things, putting data in the public domain. We're also in conversation with DETI, which we hope the development of a new center of excellence for offshore wind will carry on the back of these license options to do more research, to do more, to get more expertise back into the market. So I'll leave that there, and I want to just plug Josie Taylor here, who's going to come up next, who's going to talk about the next very, very important component of this, and this is public engagement. So, Josie.
Hi, so I'm Josie Taylor, a new postdoctoral fellow on the ENACT project, Energy Narratives and Change in Coastal Communities in Ireland. So my proposal is that energy transition is not just about the technology and the infrastructure, but about the social and cultural. So what is it? What is ENACT about? So ENACT is a project that focuses on coastal communities in Ireland, thinking about the ways that they feel about the oncoming energy transition. What is their specific narratives and how do they relate to this change happening in their community? So our project aims are to develop community narratives of energy transition. And we're an interdisciplinary team. We combine the methods of environmental humanities, engaged research, and social science. So we use theoretical perspectives from the humanities and use data collection methods from the social science. So where are our fieldwork locations? So first of all, we have Whitegate in County Cork, and it is home to the only oil refinery in Ireland. And close by is ESB-owned Ahada power plant. Now, the nearby marine areas of this area have been designated and proposed for offshore wind energy. The second location is Kilrush in County Clare, and it's home to Money Point. The Green Atlantic at Money Point plans to turn the area into a hub of renewable energy by 2050, so also transitioning to offshore wind energy. So there are our two fieldwork locations where we'll be interviewing community members, hosting focus groups, and so on. So how do we gather these community narratives? What is our specific approach? So first of all, we follow an engaged research method. This is where participants can have direct involvement over research and creation. And we do this through working groups and feedback of research questions. Secondly, a technique that we employ, and we did this in our kick-off meeting in Kilrush last October, is a technique called deep mapping. And this is about learning personal narratives of place through tracing community cartographies of areas and how they map their areas through their own personal history. So not just thinking about what is this technological site mean for offshore wind, but what does this mean to the people of the community? And you can see our deep mapping exercise next to our ENACT poster. So why? Why is this research significant? What is its impact and importance? So the project values the importance of emotional, social, and cultural dimensions of energy transition. So we want to ensure that all community voices are heard and commit to a just transition. Secondly, we have a variety of outputs. So our research will include policy briefs, an exhibition that's hosted at the community centres and here at UCD, and journal articles. And this is, again, to elevate the community voices and their experience. So we also plan to ensure policy impact by partnering and communicating with ESB and local climate community officers in each region. So our project is about elevating the voices of the community so a just transition is ensured. Thank you.